This video is going to be on what I call final and initial state problems for gases. Okay, so remember, gases have the ability to expand and contract much more than solids and liquids do based on temperature changes and pressure changes. So these problems, we're going to do the little proportion that we've kind of determined over time here. So remember, we talked about PV over NT is a constant. So pressure times volume divided by N is the number of moles divided by temperature. That ratio is a constant for gas. It's called the ideal gas law. And if you multiply those and divide by these, you always get 0.0821. Okay, we set that up, we've done that. So I can set this equal to the exact same proportion. So I'm going to set up a little proportion here and say, well, if we have a gas at these conditions, what if I change the pressure and the temperature? Or what if I change the number of moles and the pressure? What happens to the volume the gas takes up, something like that. So we can set this up. We will not use moles for these problems right now. We will eventually later in the year, but we haven't got into moles yet a whole lot, so we'll hold off on those. So in this case, this gives you a gas at this temperature and this volume. It wants to know if the temperature goes to 50 degrees, what's going to happen to the volume. Well, notice temperature is going from 25 degrees to 50 degrees. So the gas is going to get bigger. Common sense would tell you, well, the temperature is doubling, so the volume will double as well. The only issue is our temperatures have to be in Kelvin here. They cannot be in degrees Celsius because we could have a negative Celsius temperature would make us have a negative volume, which is not possible. So we do have to convert our Celsius temperatures into Kelvin, so just take your Celsius temperatures and add 273. So plus 273 is 298 Kelvin. For some reason, they don't use a degree sign with Kelvin. Plus 273 is 323 Kelvin. So notice the Kelvin temperature is not doubling, so the volume will not double, but it will still get bigger from here to here. The other thing is pressure is staying constant. So pressure is, it doesn't matter what you put in for pressure, it's staying at 1 atmosphere or it's staying at 5 atmospheres. So the pressure is not affecting the volume. The only change that's affecting the volume of the gas is temperature. The number of moles of gas is not changing as well. So in this case, since the pressure is staying constant, we can just remove it from the proportion. Or we could put a 1 in there if we wanted to on both sides, but we'll just take it. So now we have V over T equals V over T. That's a direct proportion, remember. As temperature increases, volume goes up. So just plug in our numbers. So 200 liters, gas takes up 200 liters of space at a temperature of 298 degrees Kelvin. So what volume will it take up at 323 degrees Kelvin? We're going to cross multiply and divide to get our answer. I do not have that right now, but again, I would cross multiply this direction and divide here. Do that real quick. So I would take 323 times 200 divided by 298, 216.8 liters. So notice the gas, as we heated it, it now takes up more volume. Next problem down here, notice we have pressure and volume, pressure and volume. So let's just think about what's going to happen here. So temperature and amount of gas is not changing. Temperature and amount of gas is not changing. Notice the volume of the gas is getting bigger. The gas is spreading out. That means there must be less pressure on the gas, allowing it to spread out. So our pressure should go down. Remember, this is an inverse proportion. So if you write up a proportion PV over T equals PV over T, since temperature is not changing here, we can just ignore the temperature. So if we take the temperature out of this proportion, we just have P times V equals P times V. Again, that's an inverse proportion. So I would say, well, so we got PV equals PV. So I'd say at 101 kilopascals, there's 20 liters of gas. So what pressure would it take for the gas to get to 30 liters? So I'm going to now multiply these two and divide by 30. So I want to get the variable by itself. So I'm multiplying here, dividing by 30. So, and again, 101 times 20 divided by 30 is 67.3. kilopascals. So we would have to decrease the pressure from 101 kilopascals to 67 kilopascals to get the volume to go up by that much. I'll show you one more quick problem here. This one's going to have pressure, volume, and temperature involved. So notice here we've got pressure, temperature, volume. So you have a gas at this pressure. Remember that's 760 is normal there. You don't have to convert pressures. You can keep those the same. Only temperature has to be in Kelvin. And then we're changing it to this. Let's just think about what would happen to the volume here conceptually without doing any math on it. First of all, the temperature is going down, getting colder, so that should make the gas take up less space. Pressure is going up, meaning there's going to be more pressure on the gas, which would make it take up less space. So our volume should be less than 100 milliliters when we do this. So we'll put these three in together for PVT, put in P and T on this side, and solve for V. So I'm going to go 745, that's our pressure, times the volume is 100, over our temperature, which is already in Kelvin, 293. So there's that. We'll set it equal to the other side. Equals 760 is our pressure. Trying to find the volume, so that's my V. Sorry about this part right here. It doesn't confuse you too much. Over our temperature, which is 280. So here's our setup. So plugging numbers in shouldn't be too hard for you to do. PVT, P, V's are variable, T. So again, I'm going to cross multiply and divide. So here's my rule. Cross multiply where there's no variable. So I want to multiply 280 times 100 times 745. So I'm going to multiply this direction and then divide by every number it's left over. Divide by 293, divide by 760. So cross multiply, divide, divide. Get your volume from there. I'll let you guys get an answer to that. Again, your volume should be less than 100 milliliters when you get that answer.